A colleague was teaching a statistics or data unit and asked me to work with a small group of students to extend their thinking in relation to pie charts. So I set myself a challenge to see if I could reason through the mathematics task involved. Firstly, could I convert a number to a percentage? Secondly, could I convert the percentage to degrees for the pie chart? Here's the context. Favourite movie genre. Surveying 20 people, 6 out of the 20, their favourite movie genre was romance. 5 was action, 4 for comedy, 4 out of 20 for sci-fi, and 1 out of 20 for drama. My task, to determine the percentage and the degrees for the pie chart by reasoning. Okay, let's convert our raw scores to percentages by reasoning. If 20 out of 20 people loved a certain genre of movies, 20 out of 20 would be 100%, the whole lot. We can get from 20 to 10 out of 20, well, that's just halving. And we're just halving. So to get to the percentage then, we can just halve 100%. That will be 50%. Then to get to 5, we can just halve again. So let's halve our 50%. That'll get us to 25%. So 5 out of 20 is equal to 25%. So that's our 5 out of 20 done. To convert 1 out of 20 to a percentage, we can connect 10 out of 20 to 1 out of 20. And we could divide it by 10. 10 divided by 10 is 1. Then 50 divided by 10 is 5%. So that's our 1 done. To convert 6 out of 20 to a percentage, then we can connect our 5 out of 20 plus 1 out of 20. That gives us our 6 out of 20. So then we just add our 25 and 5. So 6 out of 20 then is 30%. That just leaves us with the 4 out of 20 to convert to a percentage. Here I can multiply the 1 by 4. That will get me to 4 out of 20. And then I can just multiply the 5 by 4. And that will get me to 20%. So 4 out of 20 is equal to 20%. So I've just converted the raw scores from this column here to a percentage. Next task. Let's convert the percentages to degrees for the pie chart via reasoning. 100% of a pie chart is a full rotation, so that's 360 degrees. Now I can get to 25% just by halving. So let's start at 100%. We can halve that to get to 50%, and then we can halve that again to get to 25%. So then we're going to do the same thing in terms of the degrees. So let's go from 360 degrees, and we can halve that, and that'll get us to 180 degrees. Then we can halve it again. That will get us to 90 degrees. So that's 25% done, converted. Now, how can we get to our 20%? So we've got 20 to 100. So 5 20s is 100. Let's document this. 5 times 20 equals 100. So that means for our degrees, we're going to have 5 times something equals 360 degrees. So I know that 5 times 70 would equal 350, and I can get there from knowing that 10 times 7 equals 70, so half of 70 equals 35. So that's a connection we could use there. So if we know that 5 times 70 equals 350, that's just 10 more that we need. So we just need another 5 lots of 2. 5 lots of 2 equals 10. There's our 360. So altogether, then that's 5 times 72 equals 360. So 20% of that would be equivalent to 72 degrees. Here's another way we could get to the 20% and convert it to degrees. So if we start off at our 100, I'm going to connect 100% to 10%. So let's just put in 10%. Okay, so from 100, I'm going to connect 100 to 10%, and that would be dividing it by 10. 10 tens are 100. 100 divided by 10 equals 10. And then in terms of getting that to degrees, we've got 360 degrees, and we're going to divide that by 10, which would get us to 36 degrees. Then we can just double the 10% to get to 20. And if we double 36, we get to 72. 72 degrees. So that's another way to get to 20%. Let's convert 5% to degrees. So we could just halve our 10%. Half of 10 is 5. So then we can halve our 36 degrees. That would get us to 18 degrees. Finally, let's convert 30% to degrees. We could triple the 10% and then triple the 36 degrees to get to the conversion. So let's document that. 3 times 10%, which is our 30%. So we do 3 times 36, and that would get us to 108 degrees. That's one way. Another way we could do it, we could take our 25 and add another 5% to get to our 30. 25% plus 5%. So that's 90 degrees plus 18 degrees equals 108 degrees. And one other way we could do it is we could take our 20 and then add the 10%, 20 and 10%. 20% is 72 degrees. Then we've got 10%, which is 36 degrees, equals 108 degrees. So there you go. I've been able to convert raw scores to a percentage and convert percentages to degrees for the pie chart. A big shout out to Pam Harris and Kim Montague of Math is Figureoutable, who continually inspire me to mathematise and to reason in maths. This video captures my preparation for teaching students, so I want to show you some of my thinking drafts. Maths is not a matter of just getting it straight away. It's about iterations and drafting and rethinking and redoing. And here's my teaching whiteboard that captures the students' thinking. Some interesting things came up in the class that I hadn't thought of or noticed initially. So they picked up on the idea that on the percentage side, that there was a counting by fives. So they worked out that, from, 20, 25, 30, they're counting by 5. The other thing that they noticed is from going from the raw data to the percentage side, that was a multiplying by 5. So 6 times 5 is 30. 5 times 5 is 25. 4 times 5 is 20, and so on. So it's interesting to see how they engaged and they reasoned and they made sense of the numbers and the relationships between the numbers. One more thing, one student made connections between the percentages and the fractions. So knowing that 25% equals a quarter and 20% equals 1/5. So it'd be really interesting to explore this further with that student, asking them how they know that 1/4 equals 25%, how they know that 1/5 equals 20%, and getting them to explain that, reason it out. For more videos, check out my YouTube channel, Thinking Maths with Greg Curran.